In this video, I will be showing you how I designed and 3D printed this map of our local stars within about 15 light years or so of our Sun. I was inspired to make this star map by the online star map from a website called Atlas of the Universe that I've linked in the description. I was attempting to replicate this star map more or less in the form of a 3D model. The stars that are closest to Earth are often mentioned in science fiction and are important astronomical references, so I wanted to create a 3D printed version of the map to help me visualize things and as a cool decorative piece. In order to create the 3D model, I wrote a Python script that queries the simbad astronomical database for star location and used open-sourced CAD automation software called OpenSCAD and Solid Python to automate the generation of the 3D model. So now I'll jump into a little bit about how the code works. So the first step in the code is to configure our simbad query to have all the information we need to plot the stars on our star map. So the first piece of information we'll need is this PLX field, which is going to be the parallax, and that's going to tell us how far the star is away from Earth. And we're also going to need to add fields for getting the right ascension and the declination, and those are going to basically be two different angles that are inside a spherical coordinate system. So based on the distance and these two spherical coordinate angles, we can basically know exactly where the star is relative to Earth. And the Atlas of the Universe map is kind of centered on the galactic ecliptic. So that's going to mean we're viewing the map as if the galaxy is kind of laid flat on a surface. So that's what this GAL configuration right here is going to be. So the next step is to basically start constructing a list of different stars and their distances from the Sun in kind of a rectangular coordinate system, so X, Y, Z. So the first step for there is I have a list of stars and a text file that I then read in, and then for each of those stars I call this function called getStarInfo, and that will basically query the simbad database, and we get a result back with our angle and also our parallax. And then based on the parallax, we can calculate the distance in light years. So that's what this does. And then I have two different passes where I first kind of convert the distance and the angles to a spherical coordinate system. And then I convert those to a rectangular coordinate system using a bit of trigonometry. And then I can return the name of the star as well as the X, Y, and Z distances from the Sun. And then once I have all that info, I can then feed that into the OpenSCAD logic, which will then allow us to kind of construct a 3D model. So what I'm doing here is I'm first creating a bunch of cylinders based on the star data. So I can center the cylinder basically based on where the XY coordinates are, and then I can extrude the cylinder based on how high the Z coordinate is. And then I'm also kind of popping out a cylinder in the center with a negative volume in order to have a place where I can thread LEDs through. And once I do that, I can return the resulting SCAD code, and that's pretty much it. Yeah. Can print that out, and then that will output to basically the terminal, so I can pipe that into a file, and that'll give me an OpenSCAD file that I can then feed into either an OpenSCAD command line tool, or I can go online and convert that directly to an STL, and then that STL can then be put into a slicer that can be put into G-code, and that can be 3D printed. A 3D printer was then used to print the star map. as well as the base which would house the electronics. After 3D printing, the spectral types of each of the stars was referenced and an LED corresponding to the star's spectral type was chosen. Long wires were soldered to each of the LEDs and heat shrink tubing was used to ensure the leads wouldn't contact each other and short. The LEDs and their wires were threaded through each of the cylinders. Optionally, all of these LEDs can be connected to a Raspberry Pi Pico or other microcontroller, which can be used to flicker the LEDs on and off at random to create a twinkling effect. Once all the electronics were assembled, the top was hot glued to the base, enclosing the electronics inside. And that's about it. This is the finished product. Hope you enjoyed, and thanks for watching.